X-rays. Subtopics: Introduction, Discovery of X-rays, Properties of X-rays, and last, Production of X-rays. Introduction. X-rays are a type of high-energy electromagnetic wave. They can pass through materials that visible light cannot. They are used in medicine, X-ray scans, security check, and research. When photons falls on a metal, it emits electrons. The photoelectric effect shows how light, photons, can release electron from a metal. A question arises: can moving electrons create light, photons? This was answered even before quantum theory was fully developed. Here you have the X-ray tube where fast-moving electrons hits the metal target and produces X-rays. Electrons converted into X-rays. Discovery of X-rays. Wilhelm Röntgen discovered X-rays in 1895. This was the first X-ray of Röntgen's wife's hand with a wedding ring. He found that fast-moving electrons hitting certain materials produces invisible, powerful rays. Since their sources was unknown, they were called X-rays. Properties of X-rays. Here you have an electromagnetic spectrum in that X-ray falls between 0.01 nanometer to 10 nanometer. X-rays are a type of electromagnetic wave with very short wavelength, 0.1 to 100 Armstrong. X-rays can pass through many solid materials that visible light cannot. Here you have a paper. The paper stops alpha rays. Then you have a human being. Beta rays, gamma rays, X-rays, neutrons passes through the human. Then you have a thin aluminium that stops the beta rays, whereas thin lead stops gamma ray and X-rays. Then finally we have water and concrete that stops neutrons. This is the X-ray tube. X-rays moves in straight line at the speed of light. X-rays are not affected by electric or magnetic fields. Quality of X-rays equals how well they penetrate. That depends on electron speed and the materials used. The electron speed depends on the potential difference between anode and cathode. The next, the material used. More is the atomic weight, stronger or high penetrating power X-rays we get. Intensity of X-rays depends on how many electrons hits the target. That depends upon the filament current. Filament current depends upon filament potential difference. Production of X-rays. X-rays are made in an X-ray tube. A tungsten filament is heated, releasing electrons. A high voltage pushes these electrons towards a metal target like tungsten or molybdenum. The target is tilted at 45 degrees, so X-rays can come out easily. When fast electrons hits the target, they slow down and produce X-rays. most energy turns into heat. So the target needs cooling and must be made from heat resistance materials. So here you have a water cycle arrangement. Water get in, this is the cool water, whereas the hot water comes out after reaching the target.